Welcome to the first lecture of the McMaster University course, Computer Science 1JC3, Introduction to Computational Thinking. This course is being given in fall 2020. We're going to start off with the topic, what is computational thinking? We can give a simple answer. Computational thinking is thinking inspired, supported, or enabled by computing. But of course this begs a question. What is computing? And in many ways, the focus of the course for the whole term will be trying to answer the question, what is computing? But we can think of computational thinking as just thinking that a computer scientist does. Whatever a computer scientist does, that is computational thinking. And computational thinking is important. It's a skill that should be part of everyone's education. So let's begin to talk about computing. What is computing? Computing is simply the development and use of computer hardware and software to do a bunch of useful things. These useful things include solve problems, manage information, create smart products of all different kinds, explore our world in various ways, and to connect to other people in effective ways. Computing is multidisciplinary. It is a mixture of mathematics, science, engineering, technology, and design. And of course, computing is found everywhere in our world today. It impacts us at every level, in every dimension. So when people think of computing, they may think of various fields. So I want to go over some of the important fields that are part of the discipline of computing. The field people think of first is what's called computer science. Now, computer science is really a bad name for what it is. Computer science is not the science of computers. It is much bigger than that. I think a better name is, it's computing science and engineering. It's the engineering and science of computing. And the interesting thing is, computing really is more engineering than science. So computer science is, in many ways, the key field of computing. It is the engineering and science of computing. But there are other fields. There's computer engineering. Computer engineering is the study and use of devices to do computing, do computation. And software engineering, which is, you can think of as a subfield of computer science, it is the use of engineering principles to develop software. Another field is information systems. Information systems is the development of computer systems and communication systems that manage information. And finally, the last field I'm mentioning is information technology. This is the study and development of technology that supports computing. Now, of course, these fields heavily overlap with each other. I mentioned that you can really think of software engineering as just a subfield of computer science, for example. Now, there are many kinds of thinking, and I've listed some here. There's historical thinking. This would be the kind of thinking that historians use. It's how historians look at the world, how they try to analyze situations and solve problems. And we have political thinking, business thinking, mathematical thinking, engineering thinking, scientific thinking, and artistic thinking. Now, remember, I said computing is a mixture of mathematics, engineering, science, and design. So these last four areas of thinking are very important part of computing. So we're going to look at these in detail. First, we'll look at mathematical thinking. Now, probably most people think of mathematics as a collection of facts. So these facts include things like 1 plus 1 equals 2. The set of natural numbers is infinite. The set of real numbers is infinite, but it's also uncountable. There's endless number of mathematical facts. But mathematics is actually much more than just a big body of facts. It is a process. And it's a process for understanding the mathematical aspects of the world. It's a process we can use to understand the world we live in. And mathematical aspects involve such things as time, space, measure, pattern, and logical consequence, and other things as well. So mathematics is a process for learning about the world, learning about the mathematical part of the world. So this process is based on mathematical models. So a mathematical model consists of objects, concepts, and facts. You can have simple models and very complex models. So an example of a model would be the model people have developed for counting. In this model, the objects are the natural numbers, either starting at 0 or starting at 1. And the concepts are things like every number has a successor. And when we count, we go from a number to the successor. And then we have facts, like if we count backwards, we have to stop at some point. So that is an example of a mathematical model. And the mathematical process creates models. It creates them, and it creates models that are meant to describe a particular mathematical phenomenon, something that is exhibited in the world. For instance, counting. In all kinds of human cultures, people have counted. What is going on mathematically when we count? Now, once you have a model, once you've created it, now you can study this model, and by studying it and expanding on finding new objects, new concepts and facts, expanding on the model itself, we can come to a deeper understanding of the phenomenon that the model describes. Let's say in our example, counting. So, for instance, we can introduce to our model the idea of addition and the idea of multiplication. These ways of enriching our model give us a deeper understanding of the world. So mathematical thinking is the thinking that underlies the mathematics process. So what is scientific thinking? Scientific thinking is quite simply the systematic study of the world through observation and experiment. So scientific thinking is centered on two things: the scientific method, and this is a method where people pose a hypothesis and then they do experiments to test the hypothesis, and they may find that the hypothesis is incorrect, so they modify it, and then they test again, and this is done over and over again until we come up with a hypothesis that seems to capture something that's really true about the world. Another aspect of scientific thinking is the formulation of knowledge on the basis of empirical evidence and deductive thinking. So science is building up an edifice of mathematical knowledge. Okay, so let's move on to engineering thinking. Now, engineering, my definition of engineering is it's the systematic and rational application of knowledge to solve problems and create things for the benefit of society. So engineering serves society. And the kind of knowledge it uses is particularly mathematical and scientific. But any knowledge can be used. Engineering can apply any knowledge to solve problems and create things. But much of the focus is on mathematical and scientific knowledge. So engineering is concerned with a number of things. For example, it's concerned with best practice. What is the best practice for solving a problem? What is the best practice for creating things for society? It's also concerned with understanding problems and products in terms of systems. So engineering does not see things in isolation. It sees things as they sit in society. And so this naturally leads to concern and interest in systems. A third part of engineering thinking is using requirements to drive product development. So if you're going to produce some kind of product, ideally you start with the requirements that you want the product to satisfy. Then you come up with a design that meets those requirements. And then you come up with an implementation of your product that meets the design. And if you do everything right, your implementation will satisfy the requirements. And when you test your product, you will test it against the requirements. So this is a very important part of engineering thinking, is this requirements-driven way of developing products. And finally, engineering is very concerned about public safety and security. Because after all, engineering is working to benefit society, and in order to benefit society, we have to make sure we keep society safe and secure. The last kind of thinking I want to talk about is artistic thinking. So if we try to figure out what art is, my definition, it's the production of artifacts that express beauty or salient aspects of the world and human existence. So when people produce art, they're motivated to capture beauty or to capture aspects of the world or humanity that are really important. And of course, really good art does both things at the same time. So artistic thinking is thinking that fosters the creation of art. And it includes such things as finding inspiration in various places like nature, in intellectual ideas, in events that have happened in the past, in just pure imagination, and in other artwork. It's also concerned for looking for new ideas and new experiences. And third, artistic thinking often works by trying to impose restrictions to focus creativity. So rather than take the approach, I'm just going to do whatever I need to do to be creative, you make restrictions. Like if you're writing a poem, you decide to use a certain rhyming scheme. And this helps focus creativity, and this is a fundamental part of artistic thinking. So now let's come back to computational thinking. So computational thinking starts with understanding computing. And if we're going to understand computing, we have to understand mathematics, engineering, science, and design, because these make up computing. And one of the best vehicles for understanding computing is learning functional programming using the Haskell programming language. So Haskell we'll talk much more about later, but Haskell is a functional programming language, and this will help us focus on the key ideas behind computing. Okay, so computing includes mathematics, engineering, science, and design. So computational thinking includes mathematical thinking, engineering thinking, scientific thinking, and artistic thinking. And I have posted on Avenue a paper by Jeanette Wing called Computational Thinking. And this is one of the really seminal papers that describes the idea that computational thinking is a kind of thinking that's separate from other kinds of thinking. So we're going to stop here, and in our next lecture we're going to look at the fundamental question of computational thinking.